Welcome back to a new video. For this next series, we're actually going to change the pace a bit. Well, mostly the topic, not necessarily the pace. In terms of cybersecurity, right, we need to understand what we're securing to better understand how to secure things. And so for the next series, uh, for the next two series, I'll be doing a few videos, not a few, but quite a large amount of videos around networking. So we better understand why we're doing everything that we went over in cybersecurity. Uh, with initially in this particular module, we're going to go over network plus concepts. So we're going to be implementing those in our exercises. And then in the next module, we'll be going over CCNA as far as different ways to different concepts of those with our exercises and videos for that portion as well. And we'll also be getting into a bit other things as well. But for now, we're going to focus on networking in this particular case. In the next on this particular series of videos, networking plus concepts. So then we can go right into CCNA concepts and the differences and the crossovers/similarities between the two. But nonetheless, we can go ahead and get started with the first exercise now. So what we're going to go over a bit first is talk a little bit about the structure and functionality of the OSI model, the data encapsulation and decapsulation process within the OSI model, as well as, but what we're mainly actively going to see us doing today is actually identify components associated with layers 1 to 3 of the OSI model, and identify components to layers 4 through 7 of the OSI model. So we can actually go ahead and get started with identifying layers 1 to 3, right? So the first three layers of the OSI model consist of the physical data and the network layers, right? So the physical layer of the OSI model is responsible for the communication between devices and deals with the physical connection to a network. So after a connection has been established by the physical layer, the data link decapsulates the packets to form frames, which are passed to the network layer. Then the frames received from the data link layer are then sent to the network layer, which then determines where the frames need to be sent to the headers, which contain the routing information for these frames. So the network layer just pretty much allows us to move traffic to networks, not directly inside. So as you can see here, I've opened the network and internet settings, right? I'm just going to do a few things here. So I'm actually going to open up the properties for here. And by the way, this is in the page adapter options that I'll show in a minute. So now for properties, I'm actually going to configure some things in the Microsoft Hyper-V adapter dialog box. So I'm going to take a look at the details right now. Just as a note, I also want to mention that devices used in this lab are virtual machines using a virtual network adapters. But on a physical machine, the adapter's name will differ, as it will be a physical adapter that will be in use. Just for that heads up as far as things look different. So for the property for the device descriptor, I'm actually going to change it to LS connected, IS connected, right? And I'm going to close these out. I'm going to open it right back up. I'm just going to close them out, right? So now what I'm going to do is actually identify the data link components of the OSI model. So the data link layer of the OSI model, it consists of two components, right? So the logic link controller sublayer and the media access control sublayer. So networking components that are associated with this layer are MAC addresses and network drivers. So I'm just going to look over the components associated with the data link layer that's going to be identified. So we're back in the network settings, right? And I'm actually going to go back to the Ethernet settings and I'm going to change the adapter options again. And then we're going to go back to the properties portion for the first Ethernet, right? Then we're going to configure again, right? But this time we're going to take a look at the driver tab instead of the details, right? So we're going to look at the driver details, right? and we can see displaying in the driver tab and Ethernet adapters properties window what it looks like as far as the driver type details, and everything looks pretty good, nothing out of the ordinary. But what I will say is in the driver file details dialog box here, the specific software driver, it gets shown to us for the network adapter. Now on the physical machine, these details would differ, right? And display the network interfaces card manufacturer's drivers. So the network software driver facilitates the interaction between the hardware component and the operating system and forms part of the data link layer of the OSI model. So I'm actually going to click OK out of there. I'm actually going to click OK out of here as well. I'm actually going to bring out the CLI here. And I want to make sure it's ran as the administrator for what we need to have done on it. All right, perfect. So I'm just going to type in IP configuration, or IP config rather. Let me take a look at all of it. All right, so we can see everything from the Windows IP, the Ethernet adapter, and we see both Ethernet adapters. Now, by executing this command, the network configuration of this particular device is displayed. Now, the device's IP address is displayed as, let's see, should be, here it is. All right, so it's displayed as 192.168.0.5, and the physical address is also displayed. Now, a device's physical address is referred to as the MAC address, and this is associated with a specific network interface card. And a MAC address is a unique hexadecimal combination that is used to identify the network interface card. Now, different hardware vendors have different combinations on how these MAC addresses are compiled. And the MAC address displayed might differ with different devices naturally, right? So let's actually take a look at this command, right? So with this command, the address resolution protocol, which is the ARP here, it resolves IP addresses to MAC addresses. To facilitate network communication, an IP address needs to be assigned to the network adapter. And the IP address is then allocated to the MAC address during communication to another network of devices, right? And the MAC address functions on the data link layer of the OSI. So with that being said, right, I can actually close this out. We're actually going to open it back up here in a second. Now, what I'm going to do is identify the components associated with the network layer of the OSI model, right? And so the network components that are associated with the network link layer of the OSI model consists of the IP address, subnet mask, the default gateway, routing information. And the network layer inspects the headers of the packets received from the data link layer to determine if it has reached the final destination. If not, it will forward the packet to the correct destination, of course. Now, for the next couple commands, I'm actually going to do something similar to what I did before. So I'm going to run ipconfig all, right? Now, for the output of the command, the IP address, the subnet mask, and the default gateway is displayed. And these are core components of the network layer, right? Then I'm going to reopen this back up again, the network and internet settings, right? And you're going to change adapter options here again. But this time I'm going to do Ethernet 2, right? And then I'm going to do IPv4, take a look at those properties, right? And I'm going to use, actually, let me open this up. This IP here. On a full IP, the subnet mask is automatically filled in. And then the default here, and then there, right? Perfect. So we're good there. And the default gateways are intended to provide redundancy, to a network, that's fine, right? So I'm actually going to close this out. And do you want to allow your PC to be discoverable? Yes, we do. That is fine. And actually, while we're in the throes of doing that, I'm going to reopen the command prompt. I'm actually going to use another command here. It may be a little bit slower because I'm not using the D-pad because like the lab doesn't like the D-pad, right? Okay, perfect. Now it says okay. Now, if I wasn't the admin, it would tell me, hey, you need higher authority pretty much to do this or privilege escalation or something like that. Now, what happens is the route admin, it creates a persistent route to the different subnets, enabling communication across different subnets through the router. So now I'm going to route the print, right? Now, what this does is it displays the routing table of the device after configuring the network adapter with an IP address. And the network layer is then going to facilitate the communication to the newly allocated subnet by inspecting the packet headers to ensure it is routed to the correct destination. So now, I'm actually going to ping a router. I'm sorry, IP. Perfect. So now it's just pinging. And the ping command is used to verify that the newly assigned IP address can communicate with another device from a different subnet. So now what I'm going to do is, now that I've identified layers, um, the layers 1 to 3, now I'm going to identify the layers 4 through 7, right? That comprises of the transport, session, presentation, application layers, right? So what I'm going to do, I'm going to do a few exercises. We're going to identify components of the transport layer of the OSI model, then identify the components associated with the application layer of the OSI model. And first, to illustrate this, I'm going to start with identifying components of the transport layer, right? So several different protocols operate on the transport layer of the OSI model, right? And these include TCP/IP, Transmission Control Protocol, and UDP, User Datagram Protocol, right? And I'm just going to take a look at the different protocols that I use for specific connections, right? So I'm actually going to open back up the command prompt for an as administrator, of course. Okay, perfect. So now what I'm going to do is that we're going to look for TCP, right? So the different TCP connections, right, to at least the device that we have when 10, they're displayed, including the connection statistics, right? And the statistics, of course, are going to vary, and the different ports that these TCP connections use are also displayed. And this information can be used for like troubleshooting, determining which remote devices are connected to the local device. And TCP connections are actually connection oriented, which means that it includes error checks. So we want to open up Microsoft Edge. I'm not really going to do anything with it. I just want to have it open. And then I'm going to do it again. Right. Now, after opening the Edge browser, a new TCP connection was established, as shown from the output when the command was executed. A bit different than when it was first executed. You also can notice that a connection to the internet, right, um, was established using the TCP protocol on port, let's see, port 80, looks like. And the transport layer uses the TCP protocol to establish the connection. So now we can take a look at the user datagram protocol. Just helps me here. Perfect. So we see the UDP stats for IPv4, right? And for the commands output, it can be seen that there's not currently any UDP connections, at least for the local device. Now, the DHCP service uses the UDP protocol to connect to other devices. You usually use the ports of 67 and 68. So now what I'm going to do is identify the components associated with the application layer of the OSI model. Now, the application layer receives the packets from the sensor layer and de-encapsulates them, right? Thus ensuring the application can display the output to the end user, for example, a web browser displaying a web page. So let's actually take a look to illustrate this. Let's take a look at the task manager, right? Let's see here. All right. Typically, it will look like this when it's opened up. So I clicked it, but click more details, you'll be able to see everything that I'm looking at. And then I'm going to open up Microsoft Edge again. Again, not to do anything with it, but to just have different background processes running on a device, right? So they can be displayed in our task manager. And these processes ensure that the end user, like myself in this moment, can successfully launch applications that form part of the OSI Model's application layer, right? So now that we have Task Manager back up, we're on the Processes tab, right? So it sees everything that's taking up memory, CPU, disk, network percentages, things of that nature. So the applications on the device nonetheless can be seen in Task Manager, right? And we also can now see Microsoft Edge, right? And I can actually expand it and what's running within it, right? To total everything that's in this very last box here. So I'm going to close this out. That'll be seen that. I mean, everybody has pressed Control Alt Delete, right? Take a look at these things, but we have reached the end of the video. As far as the introduction to the OSI model, we identified components associated with layers 1 through 3, and we also identified components belonging to layers 4 through 7 of the OSI model, with identifying different components of the transport layer and associated with the application layer of the OSI model as well. Now, while this was an introduction, we're going to definitely be back with another video. Next one is going to be on the networking topologies and their characteristics, which should be even more fun. Hope to see you there. Stay curious, stay secure.